there, I'm Professor Rad, and this is Precalc video 228, exponential and logarithmic inverses and their domains. So in this video, we will be finding the inverse of an exponential function and the inverse of a logarithmic function. Now, we've already been discussing how exponential and logarithmic functions are inverses of each other. So we will be using that to help us write the inverse of more complicated, messy looking things. So to help us out, I'm just going to put a reminder on the side here. If you have a to the x equals y, another way of expressing this relationship would be to say that log base a of y equals x. So if we have an exponential expression, we can write it as a logarithmic equation and vice versa. So remember that in order to find an inverse of a function, you need to swap the roles of x and y. So right now, this is like y equals 2 plus log base 3 of x plus 4. So instead of y, I'm going to start out by writing that as an x. And then I'm going to rewrite this equation. And instead of x plus 4, I'm going to have y plus 4. And now our task is to solve for y. So the first thing we're going to do when we're trying to solve for y here is I want to get the logarithm, in this case, by itself. So to get the logarithm by itself, that means I need to move this 2. So I'm just going to subtract 2 from both sides. This will give me x minus 2 is equal to log base 3 of y plus 4. Now I have a logarithm all by itself, and it's equal to this other thing. So in order to free the y plus 4 from the inside of the logarithm, I'm going to need to rewrite this without using the log. In other words, I need to go from this form into the exponential form. So remember the cyclic nature to this. We're going to take a to the x equals y. So, I mean, my logarithm's on the right this time, but it's the same idea. We're going to take 3 to the x minus 2 equals y plus 4. So we have 3 to the x minus 2 power is equal to y plus 4. And then to solve this for y, we need only to subtract 4 now. So I subtract 4 from both sides, and I get 3 to the x minus 2 minus 4 equals y. Putting this into my inverse notation, I can say f inverse of x is equal to 3 to the x minus 2 minus 4. Okay, so for the other part of this, we had to find the inverse of each function and state the domain of the inverse. So in the end here, we ended up getting an exponential function. Exponential functions have a domain of all real numbers. Logarithmic functions, we have to make sure that the inside of the logarithm is greater than 0. So because we ended up with an exponential function in the end here, our domain is just going to be all real numbers. So the domain is going to be all reals. Easy, right? I hope so. So let's take a look at this other problem. So here we started with a logarithm and we ended up with its inverse, which is exponential. Now we're going to start out with an exponential function and find its inverse, which should be logarithmic. So to start out, I'm going to change the roles of x's and y's. On this particular problem, we have t, but I'm just going to use x and y to keep it easier, knowing that in the end, I do want to change back to n and t. So let's see here. We're going to get, this is y, so I'm going to change this part into x, is equal to 50 e to the negative 0.2 y. Okay, when you are trying to find the inverse of a function like this one, your goal is to get the exponential piece all by itself. So what I mean by that is the e to the minus 0.2y. We want to get that piece by itself first. So that means we have to do something with this 50. So let's divide both sides by 50. When I do that, I get x over 50 is equal to e to the negative 0.2y. Now, typically we're going to keep things in fraction form, but I'm going to change this into decimal form just because we have a decimal already set up over here. So let's keep our values consistent. So putting this into decimal form, we're going to get, let's see, 1 over 50, that's the same as 2 over 100, so 2/100. So I'm going to get 0.02 x is equal to e to the negative 0.2y. Again, there's nothing wrong if you want to keep it in fraction form. So if you wanted to keep this as x over 50, that's totally fine. Now that we have an exponential expression equal to something, we're going to change from exponential form into logarithmic form. What this will do is it will free up the exponent. It'll bring the exponent back down into the land of the living so that we can solve for y. So same thing with our cyclic motion here. The base of the exponential expression is the base of the logarithmic. So we'll have log base a of y equals x. So here, because our base is e, we're going to get the natural log. So we're having log base e, or the natural log, of 0.02 x is equal to the exponent of negative 0.2y. All right, and now to finish this up, we're just going to divide both sides by 0.2, and that will give us y. So we have the natural log of 0.02x over a negative 0.2 equals y. And I'm going to leave it like that. I'm not going to get super fancy with simplifying this. If you wanted to, you could multiply top and bottom by 5. That'll clear the decimal. So actually, yeah, why don't we do that? So if I multiply top and bottom by 5, by the way, I'm doing 5 because 0.2 is the same as 2/10 or 1/5. So if I multiply top and bottom by 5, that will give me 5 times the natural log of 0.02x over negative 1, right? Yeah. Cool. Not too bad. There we are. Now, so that's, oh, and then let's make sure we put it into our inverse notation. So we had n of t, so this is going to be n inverse of t will be negative 5 times the natural log of 0.02 t. So that's our inverse function. Hooray! Now we're not done yet because we do need to find the domain, and because our inverse is a logarithmic function, we do have to do a bit of work to find the domain here. So let me find where I threw my eraser. Here we go. And we'll work that out over here. So remember, when you're finding the domain of a logarithmic function, you're going to take the argument and make it greater than 0. So in this case, I have to make sure that 0.02t is greater than 0. Now here we can just divide both sides by 2/100 to get that t is greater than 0. So this just means our domain is going to be from 0 to infinity. There we go. That didn't turn out to be so bad, finding that domain. All right, so that's going to be it for this video on finding inverses of logarithmic and exponential functions. I hope you found that helpful. In our next video, we're going to be taking these concepts of essentially solving this equation for y to solve equations now. So now we're going to have some techniques for solving logarithmic and exponential equations that are a little bit messier than ones that we've looked at previously. So I hope you have a fantastic day, and I look forward to seeing you soon. Bye for now.